The acid, also base, strength is closely determined by its molecular structure. From the structure, we can evaluate the possible acid strength of one molecule from the viewpoints of the following. Bonding strength, to what extent the hydrogen is bonded to the molecule. We have to think the electronegativity of the atom. The bond is of sigma or pi bonding. What about the bond length? Longer bond length usually indicates weak interaction, or say weak bonding. What about the total polarity of the molecule? Or the bond polarity, for example, ionic bonding tends to dissociate and give proton. And of course, we need to check the electron with the joining group will affect or not. For binary acids, we found such trends of acid strength change periodically, as shown here on the table. From left to right, the increase in the polarity of the HA bond dominates, though the HA bond length decreases. From the top to bottom, the increase in the HA bond length dominates, though the polarity of the HA bond decreases. For oxo acid, we need to consider the effects from both central atoms and the terminal oxygen. In the example on this slide, you may notice the chlorine atom in the center of perchloric acid has the highest electronegativity, and it also has the highest number of terminal oxygen atoms. Consequently, it's the strongest acid among the three. While sulfuric acid molecule has 2 terminal oxygen atoms, and also the electronegativity of sulfur atom is higher than the phosphorus atom in phosphoric acid. It takes the second place. It's summarized that for inorganic oxo acids, acid strength increases as the number of terminal oxygen atoms increases, and the electronegativity of the central atom increases. For organic oxo acids, acid strength increases as the number of electronegativity atoms in the R group increases, and the distance between the electronegativity atom and the COOH group decreases. Question: why chloroacetic acid is a stronger acid than acetic acid? Let's check the chemical structures of the two molecules. Both has the same carboxylic group, but in chloroacetic acid, there is a chlorine atom with high electronegativity, shows high electron withdrawing capability. Then we can deduce that chloroacetic acid is a stronger acid than acetic acid. If an ion is stable, it's unlikely to be protonated, or say reprotonated. We can say the more stable the anion, the stronger the acid strength. See the table shown here. The stability of the anions increase with the atomic number, and the corresponding acid show the same increasing acid strength. So does it down the column. It's generalized that the more electronegative atom is better for bearing inactive charges. The larger the atom is better for accommodating more negative charges. The stability of an anion increases if more electron withdrawing groups are available. The stability of an anion increases with electron delocalization.